No.
Krishna? Krishna, can you hear me? So you have done K means somewhere in college or somewhere? So the Krishna and Piyush haven't done. Deepak has done. Akshat, obviously you have done this.
Oh, yes, sir.
Okay, perfect. Uh, okay. So I don't think so many other people will join. So we can start off. And the recording is going on. Uh, okay, so what exactly and how is this relevant for the project? So yesterday itself on call, like Deepak had suggested that we will use some clustering. Also, not only for patent spike, but for the journal, this thing, digital cognition, and a few other things which will be there for pricing intelligence and other things. Um, Clustering is very much required. So why is clustering required? Uh, so here only I've said unsupervised manner. We will create classes in an unsupervised manner for our patents. Today something really unfortunate happened. So Sahil Oberoi and me, we got into some argument. He's been trying to tell me that he will contribute in the project, this, that, and all that stuff. He's not doing that. Unfortunately, some issue was there with him. So again, so there also he was suggesting that we go ahead. The only suggestion that I've seen from him till date, that is also something which is weird. He's saying go ahead and look at that website. It will give you classes of patents. That is not how it will work. What Deepak, me, and all of us we discussed yesterday, that is the right way of doing it. When we say unsupervised learning, we are using to classify some data into clusters. What we basically mean is we will see over here. So let's say you get some data set and you create a scatter plot of that. Okay, like yesterday itself I tried to explain that let's say we were to again take the same this thing. Everybody tell me, what is your height? Piyush, what is your height? My height is 5 feet 7 inches. Okay, so mine is 5 feet 7 inches. 5'7". Okay, what is everybody else's height? Krishna is saying 5'8". Perfect. Akshat 5'9". Excellent. Piyush, what is your height? Yes, Deepak, this is okay. You just read through this very fast so
Yeah.
that, after 10-15 minutes, you can start off. Till then, I'm also using same data set.
Yeah, so I have read it. I'm ready.
Wait.
Yeah,
Wait for 10 minutes. Okay.
sure.
So see, okay, so these are our heights. Let's say Piyush is also say 5'7" or 5'8". Okay. So one we have got one variable that we have for each and every person is height. The second variable we can look at is our the first name starting with a certain letter. So in that case, okay, all of us might be different, but doesn't matter. So let's say, do we have the letter K in our this thing, in our names? So yes, we have the letter K. Deepak also has it. Akshat also has it. Krishna also has it. Piyush and me don't have. Okay, so Piyush and me have the common letter D. Okay, my second name starts with D. His second name starts with D. Nobody has first name as R. So okay, so some kind of this thing, that is another variable that we take to classify ourselves. Now, if we start looking at such variables and then we understand that we will go ahead and create these variables, no problem, Piyush, that is okay. So if we go ahead and create these variables, and accordingly, then we start doing a classification as to which person lies in what kind of cluster. Then that is called supervised this thing. right? So everybody understands what is supervised, that you have understood what the this thing is, what the inputs are, and you understand what the output will be, and then you are trying to create a model, then you're trying to fit a statistical model or a machine learning model. So that is supervised learning. Is everybody clear on this? Yes, yes, Krishna, dividing on categories to theek hai, that is okay. You got the right understanding. What I'm saying is dividing on categories when we are aware that this is the data set and these kind of categories we have, and what is it that we want to reach. You know, so let's say if I give you an example of a flower, I say the flower's color is yellow, or it is orange, or it is red. So basis these three things, that is different colors of the flower, that is one variable. And also the flower stem is either 6 feet long, just as an example, or it is 4 feet long, or it is 2 feet long. Okay. Then I have given you one more variable. That variable can take how many values? The stem, this thing, length variable, uh, can take how many values? Krishna or Akshat, can you tell me the stem variable that I am talking about can take how many values? It can take only three values. It can either be 6 feet, it can be 3 feet, or it can be 2 feet, or whatever it is that I said. So that is how we will approach something which is what is happening. People are joining, then leaving. I think there is some issue with the network. Okay. Anyway, so that is a situation where we have taken different values for the variable. Now what is happening is that is called supervised learning. We have understood what kind of values can be taken by the variables, and we also understand what the target will be. But let's say we don't want our model to understand these things. We want a model. Okay, okay, no problem. That's okay, Piyush. Uh, so that is one thing. In the unsupervised scenario, what will happen is that we will not provide our model with the this thing, with the target variable. The target variable will not be provided as part of the training set or as part of the test set. So what usually happens in supervised learning is that when you get the entire data, so entire data is usually a sample of the population. Once you take the sample of the population, you further divide that sample of the population into a training set and a test set. The usual split that you do is a 20-80 split or a 30-70 split. That is the most usual scenario. Okay. Now what will happen is within that training set and within that test set, you will have certain variables which will be the uh, the variables which you will use to predict the target. So these are called independent variables. The target is called a dependent variable. Why is it called a dependent variable? Because what value or what class the target will take is dependent on these independent variables. Now, why would you call it independent? Now, our height is an independent variable. It does not really, depend on anything related to the issue or to the problem that we are trying to predict. But let's say we have to predict some kind of class or some kind of category or some kind of cluster that we have to put ourselves into, then that is dependent on this independent variable, which is height, or that is dependent on this independent variable, whether we have k in our names or not, or whether we have some other alphabet in the names or not. So is this understanding okay? Piyush, have you understood this? Krishna, did you understand what I said? Akshat is already understood. I know Akshat is already aware of these things. Okay, so this is very simple terms that I'm explaining to you. It's a very layman kind of explanation. So if you understood that, then we will look at this situation. Now, clustering is unsupervised learning technique. So when clustering is happening, we don't have anything as the target variable, or we don't have anything as the dependent variable. So that dependent variable and that target variable, automatically it is generated. So we are not telling the, we are not giving a data set prepared in this manner to the algo where the classes are already defined. So this is what the discussion was yesterday for patent spike also. So we are not defining as to how many. Can you guys see my screen? You can see my screen. Yeah. Okay. So we are not necessarily defining how many classes we will define, or how many clusters we will categorize the patents into. That we are not doing. We will use unsupervised learning to reach that conclusion. Is what all of us discussed on the call yesterday, right? Perfect. So now aim is to minimize total sum of squared distances from each point to mean point of a cluster. What this basically means is that, let's say we were to create clusters randomly to begin with, then whatever points are the initial this thing points which are near the clusters, they will come closer and closer as we proceed with this algo over a period of time. They will come as close as possible to the centroid of the cluster. Now, the second point is the centroid of the cluster over here need not necessarily be a point which is part of that cluster. It can be an imaginary point also, or it can be a virtual point also, so to say. Just like let's say you have certain numbers which are which are odd numbers. If you have odd numbers, I'll just do that over here. If you have a set of odd numbers which is, say, so how many are these? These are 6. Let's say you have these many. Okay. So this is a set of odd numbers, whatever they might be. It could be, I could give you a list of odd numbers, or let's say they are part of a variable or whatever it is. These are odd numbers, and I want ask you, okay, give me a median of these numbers, right? So a median of these numbers need not necessarily be a number which is actually here. It can be a number which is not part of this, but again, you'll say, okay, fine, that is the median of, no, sorry. I'm giving you the wrong example. That is a medioid example. Let me say, if I were to ask you, what is the average of these numbers? Okay.
Hello.
Yeah, Deepak.
Yeah. So sorry, I my connection was not available, so I could not connect.
That's okay, not a problem.
Should I? Yeah.
Yeah, Krishna? Yes, we are searching for best possible centroid. That is correct. Okay. So that is what we want to do. So when we take the arithmetic mean of the points belonging to the cluster, that might not be a number which is actually here. If you take an arithmetic mean of this, you will get a number which might not be actually existing within these numbers. So which is okay. So that doesn't matter. So each point is closer to its own cluster center than to other cluster centers. So let's say we end up creating 4 or 5 cluster centers. Then what we have to ensure is that each point is closer to its own cluster center is centroid. Like Krishna said right now, is it centroid that we are talking about? Yes, centroid is what we are talking about. Okay. So then we will pick an initial value for k, which is also the count of clusters and which is also the count of centroids. Obviously, because every cluster will have one centroid. So we initialize some value of k. Now, in case we are initializing the value of k, in sklearn, which we are using right now, the default value they give us 8, but we need not use 8. So okay, we can start off with 8 also. That is okay. That's a default value. but we need not use 8. So we'll use different values, and then we'll see as to what gives us the best results. But this is all just imports and all simple stuff. This you guys can understand yourself also. So this we are loading the data set, which is an inbuilt data set within this. So Iris, that's the most common data set. So if we were to print the shape of this, so now here there are two questions. In case you are not only aware, this is important to understand because it's a very common notation. So the capital X and the small y. So why do we choose this? So in most cases, what we'll do is whatever is our total data, that will be represented by a capital X, and what is the target this thing variable or the dependent variable, that will go and we'll show that by the small y. So that is all that is there. Nothing very fancy. So both of these are NumPy arrays. Now you have these different shapes of these NumPy arrays. Can somebody explain to me why do we have this different shapes? Why do we get 150, 4 and 150?
Yeah, I can explain this.
Yeah, Deepak.
Hello.
Yes, Deepak,
Yeah,
go
so
ahead.
basically it is saying that it is explicitly defining that this particular array is of one dimension and not two dimensions. So sometimes some people would define 150 comma 1, which is like a two-dimension array, but if it is 150 comma nothing, then it is a one-dimensional array.
That's correct. What I'm asking is that in this particular case, why are we getting like this? What is it?
Sorry, could you repeat?
I'm saying in this particular case of Iris dataset, why are we getting 150 comma nothing, and over here we are getting 150 comma 4? How do we understand this? I mean, let's say we.
So I guess that word target will represent second column.
Akshat, your voice is breaking, but I could understand that you are saying that the Y is the target, this thing. So that's just a single column. And the other one is, the other one is, yeah. So that's right. Perfect. Great. But let's say you were to just look at the shape of this and you don't know the data set and all, so it will not make much sense. So let's print X. So even if you print X, what is it that you see over here? So you don't get to see much. You don't understand this. So our point is that we need to understand. So we create a data frame out of it, simple data frame. We give this labeling. We can only give this labeling if we are aware as to what these labels are, right? So in this case, we are aware, so we have gone ahead and given this labeling. But what if we don't know what the labels are? Then how will we give this labeling? We cannot give this labeling. So in our scenario, when we do something similar for our patents, we will probably not know what these labels are. Okay. So again, we have to think through that task. This is okay. This is a very simple task. We picked up some data set from somewhere. World ka most common data set. Okay, so it is very simple to understand. So any which ways that this is okay. So we'll go and plot that DF. We'll look at that DF. We'll do something. So I've done this 90 to 96 by trying to see if we get all the target labels over there. So 0, 1, and 2. We can see that mostly it's a sorted out data set. Very simple stuff. That's okay. So there is nothing much over here. Then you just go and create a scatter plot. You create the scatter plot over here. You can see that we are creating a scatter plot for two of these things, sepal length and sepal width. If you create a scatter plot for sepal length and sepal width, it will already show you some kind of clusters are there. Okay, which means the data set and you can see the pink ones also mixed in the middle. So what you will understand is that sepal length versus sepal width will probably not be such a good variable that it will not have a lot of variation within the data points, and it will not create very distinctive clusters. If you look at the other one, which is this is sepal length versus sepal width. And if you look at, why is this again the same? I think I made the same one. Okay. Then if you look at petal length versus petal width, over here, you see now you have a very distinct, blue cluster at the bottom. And on top right, you have a very, again, distinct cluster. And you have something mixed in the middle, which is pink. So which means petal length and petal width are, much better variables, which will explain our data set and will create much better clusters. So similar case like we looked at our height earlier. So if we looked at our height, most of us are almost of the same height, from 5'7" to 5'9". There is not much big difference. But if we were to look at our names, then our names are different. So this is almost like, plotting our names and getting different clusters. And this is almost like, plotting our height, or maybe plotting something else, which could be our hair color or our eye color, which will not give us a very, very distinct cluster. So we also have to understand ultimately that when we start looking at our patent documents, or when we start looking at anything, which will be the variables which will explain the clustering the most. So those are the variables that we need to basically focus on, and we have to ensure that we have such variables, because over here these variables are there. What if you don't have such kind of variables? Then whatever clustering you do, whatever it is that you do, you will never be able to use this particular, k-means to reach any conclusion. Now here, this is just a normal scatter plot. There is nothing to it. Then down here, again, just pulled in this one sklearn this thing k-means function, defined 3 clusters, and this is what we get. So this is the difference. So if you look very, very carefully, over here, this point, I think, which corresponds to maybe 2.4 or something, there is a green point which is standing out. And down below, if you see this green point has become pink. So the normal scatter which is there versus the k-means has classified this particular point as part of this cluster in place of the green cluster. And the green cluster, again, on the bottom also, it's lost 2-3 points over here. And again, I think around 6-7 points have been taken away from the green cluster, and they've been added to the pink cluster, visually, if you see. And this one remains the same. So, this data set itself is such a good data set that even a normal scatter plot will show you, what are the clusters. But the same situation will not happen with real world data sets and things like that. So another thing that I have to show you. Okay, I'll do that later on. Deepak, are you there? Deepak is again disconnected. Rachit is here. Rachit, you have done k-means clustering earlier?
Yes, sir, I have done, but it has been a long time for me.
No problem. As long as, don't worry. As long as you have done it, it's okay. Don't worry. We'll share the video with you. So whatever it is we are doing, you can understand. And we'll do a follow-up session. This is just a very basic introduction session. Okay.
Okay.
Now, Deepak has left. Akshat, you want to share something, anything which is coming to your mind, you want to share? Otherwise, we'll end the call. I don't know. Deepak, where is he gone?
No, sir, right now, no, nothing to say.
No, but what I explained, is this a very basic understanding level, that clarity you have? This is okay, the way I've explained it?
Yes, yes, sir, crystal clear.
AK Shaw. I'm sorry, I forget your first name. Extremely sorry.
Yes, sir.
How are you?
It's a first day.
Oh, perfect. Okay. So you just joined, but what we'll do is, I think we'll just finish the call, because there's nothing much that we want to discuss right now. And there's another call which is coming up in another 10 minutes. So Yeah, perfect. So we'll finish the call. Piyush, Krishna, any questions, anything you want to discuss right now? Okay, perfect. So we'll just okay, perfect. So picking up a good data set is easy, and then doing something like this is extremely easy. But from understanding point of view, that is okay as the first this thing. But when we actually start doing on our real world data sets, we'll have problems, we'll have challenges that we will see whether they get solved by such simple things, or then we will go to other things. That we've already discussed many times. So perfect. Yeah. Thank you so much. Thanks everyone. And my system is not very okay. Otherwise, I could have done few more things. Thank you so much. We'll finish off the call now. Thanks. Bye.